Inverse of function from graph. Explain the technique to find inverse of the function represented graphically. Use your method to sketch inverse of the given function. So here I'll introduce you to how to find inverse of a function from the given graph. So let's say this graph is given to us. Now to find inverse, what we need to do is we need to reflect it on a line which is y equals to x. So I have also drawn a line here which is y equals to x. Take it like a mirror, right? So if you reflect your graph on this line y equals to x, then you get inverse of a function, right? That is so simple as that. And let's try to do it and see whether we really get inverse of this function or not. So first, let me identify all my points, write them as set, and then we will see how to find inverse using the graph. So let's start from these points. Let's say this point is A, B, C, D, and E, right? So point A, B, C, D, E, R, we'll say A is minus 3, minus 3. Point B is minus 1, minus 2. Point C is 0, 3. Point D is 2, 2. Point E is 4, 2. So these are the given points, and when you join them, you get your function, right? So I've drawn a line here, and this line is like a mirror for me. And what technique I'm using is reflecting my graph on this line. Now how to do it is something which I'll show you right now. So if you consider, let's start with point E, for example, right? So this point E, if you want to reflect it on the graph, then we can go diagonally like this, right? So it goes 1 unit, and so that becomes reflection of E, and I can write that as E dash. That is a reflection of E for me. Point D is on the graph, right? So it stays there. We call these points as invariant. They don't vary. They are same in the function as well as its inverse, right? Point C. Point C is on the y-axis. So that is the y-intercept. And let's see how to reflect it. So if you go diagonally, 1 and a half, you go half and 1. So you get this point as an x-intercept. That will always happen, right? So if you want to find inverse of a point on y-axis, it will land on x-axis. Let's look into point B. Now if you see from the line, it is half unit, half diagonal away. So if I reflect it, I get it right there. So I can write that as B dash for me, right? A is also invariant point. So A and A dash remain at the same place, just as we did for D, right? So D and D dash are the points at the same place. D I should represent it. D and D dash, let me write D dash, right? They are at the same place. So we got points of our inverse function, and now what we can do is just join them, right? So let me join with my rough sketch. So here A and A dash are same since they lie on the line y equals to x, right? So whichever points are like A, B, B, C, C, that means x and y values are same. They all are invariant and they won't change. So we have A and D are such invariant points. So let me join A and B dash first. So we get A and B dash. So that is the line. So I am drawing my inverse function with this color. Now C. C got reflected here, so I can join C with, anyway, let me use a scale to draw a better job. So C and B dash can be joined, there you go. And after C we have D. D and D dash are same points. They are invariant since the value x and y coordinates are same, 2, 2, right? And E for us is right there. You will also notice that the horizontal line DE when you find inverse of a horizontal line DE, it changes to a vertical line, right? So this line in pink is our inverse function for the given function. Do you see that? Now, I should say this line is inverse of the function, right? Now, whether it is a function or not is a different story, right? As we can see, it is not a function since it fails vertical line test, right? This we could have concluded from our function itself. As you can see, a horizontal line, when you take inverse of that, it becomes a vertical line, and therefore in the inverse it will fail the vertical line test. So one of the tests to figure out from the function itself whether its inverse will be a function or not is to check for horizontal line test. We call it horizontal line test. So if I draw a horizontal line and if it strikes at 2 or more points, then its inverse is not going to be a function, right? So here it is evident. So now you get your inverse function. I hope you like the technique. It was so simple. Just flip your graph on y equals to x. Treat y equals to x as a mirror. And I showed you how to count diagonals and get the new points. The other way we could do it was we got the coordinate points. Finding inverse is basically flipping or swapping the coordinates. So a dash will just swap. Instead of xy, we'll write yx. So inverse is like, it is like xy, you write then yx, you get inverse. So here it becomes minus 3, minus 3. As you can see, they are invariant points, right? They don't change. For b dash, it will be minus 2, minus 1. For c dash, it will be 3, 0. For d dash, it will be 2, 2. This is also invariant. And for e, the image of e will be e dash on the inverse function, which will be 2, 4, right? So that is another way of doing inverse from the graph. So you can adopt either method. So draw your points. Once you have all your points, you can swap them, x and y values, and get the image points. Connecting them will give you the inverse of the function, right? I hope you understand both the techniques which I have explained here. Technique number 1 is what? Reflection on y equals to x, right? That is the line y equals to x. So reflection on the line y equals to x. And the second technique which I have shown you here is to swap, interchange, you can say, x and y coordinates. So once you interchange x and y coordinates, then you get inverse. So basically xy will change to yx. So that is how you can get inverse of a function. So I'll give you some practice questions, some more graphs, and try to find inverse of those functions using these techniques. I hope that helps. Thank you.